Hey guys, today we'll be doing LeetCode number 55, Jump Game. It is a medium question on LeetCode. Now I'll get straight to it. Actually, the topics that this question covers is greedy and dynamic programming, if I'm not wrong. Greedy is something I've talked about yesterday. If you want to learn more about greedy, then I would suggest starting with the question I showed you yesterday. This one is a bit more advanced and it is pretty unintuitive at first. So the question states that if we are given an array, our end goal is to essentially reach the end of the array. That is, our goal is this essentially, n minus 1. Okay, and we consider it in indexes as well, right? Not just the numbers, but we can also consider it in indexes, because the number you jump to is the index you jump to. Now each element in the array itself refers to the maximum amount of jumps it can take from that position onwards. You can take less than the maximum, but you can't take more than the maximum. So in this case, when we are given 1, the maximum we can jump to is 1, right? And for 2, we can jump either to 0 or we can jump to 1, right? And obviously jumping to 1 is the right call, because at 0 we are dead stuck. Now that we are at 1, all we have to do is jump 1 and we will get to n minus 1, right? And it is just that. So there's possible combinations as to how you could approach this. That comes under the dynamic programming section of this question, but the approach that I will show is actually the greedy approach. Now the unintuitive part of the solution for this question is the fact that majority of the questions related to arrays go from 0 to n minus 1, right? But in this question, it is actually easier to go in reverse. So instead of going from 0 to n minus 1, we go from n minus 1 to 0. That's what the trick is in this question. N minus 2, sorry, because we already considered goal to be n minus 1. Now what do I mean by that? So I'll set up an example of, let's say, okay, so I'll show the dry run actually. Let's just do that. So first I'll consider 1, 2, 3, 4, right? And I'll consider 0 to be the goal, right? Okay, we say it is 3 right now. Okay, goal is 3. I'll draw a column here. We'll say goal is 3. Okay, now I'll go in reverse, right? Like I said, we are going to traverse in reverse of the array. We look at 1, right? We've hit element 1. It is at index 3. How do we quantify the jump we can take? Well, that's simply just I, the index, plus nums I, right? Do you get what I'm saying? So when we do index plus the element that we're at, right, that is the max, that is the distance we can jump to at best. Okay, that is immediately our max. We can take less than that, that's no worries. We care about the maximum for now. Okay, and if we do this, we see that 3 plus 1, right, we can reach our goal with this. That gives 4, which is our goal, right? Okay, so sorry, this was supposed to be n minus 1, 5. Sorry, just got confused with that. Yeah, so 4, like I said. So 3 plus 1, 4, right? We've hit the last index 4. So could we say that our new goal post is actually 3 now instead of just 4? So could we slide our goal to here, say that it's no longer 4, it's now 3. Let's remove this, right? And our goal now is to hit this. Now remember, we are not considering the possible combinations that it can reach. All we have to do is give a true or false, right? If we can reach it one way, then that means that the solution for that question should always be true, right? You don't have to explore all possible combinations or whatever, and that comes under dynamic programming. What we are going to do is just simplify it. Now the next thing that we're going to do, 2 and 0. Okay, we'll consider 2 and 0. So we'll do 2 plus 0. That gives us 2, right? But does that does that let us hit our goal? Does that, well, is that greater than or equal to our goal? Is 2 greater than or equal to 3? No, right? So now we'll just ignore this. We'll come to 2 now. 2 plus 1. Does 2 plus 1, 3 greater than or equal to 3 hit? Yes, it does. So we'll just move our goal one ahead again, right? And now our goal, instead of that, is just 1, right? And now we'll check with 1. We've got 0 plus 1, so we've got 1 greater than or equal to 1. That works, right? That works. So we'll just subtract 1 from goal again. So we'll hit 0 now. And we see that at the end, the goal post was able to reach our start of the array, right? That means that there is a possible combination such that we can get to the end of the array. And that's it, really. That's all there is to this question. The greedy pattern is the simplest version of this question, actually. If I wrote this out in code, it's literally the same thing. So this is the one good thing about greedy, is that once you do find your approach, most of the time the coding part is not an issue. The thought process, the way to come up with it, is definitely the biggest problem, right? Like I said, n minus 2 and onwards, if plus the index that we were at is greater than or equal to our goal, the index that we were on for our goal post, then we shift our goal post to that index, right? Otherwise we do nothing, we just skip, go to the next situation. And at the end, if the goal actually managed to reach the start of our array, that means there was a possible combination such that it was true, else we would just return false. So you see how the question can literally be done in just a single for loop, but the way you come up with it is the more difficult part. I'll show in the case where it's also false. This one's pretty straightforward, actually. The idea is that 0 is a dead, like it's a dead end. We would hit 1, then we would go to 2, or we could go to 1, but at the end of the day we will always hit 0. So if you consider that, if you consider our goal to now be 3, 4, 5, and then 4 is our end goal, right? And we will see 0 plus 3 is greater than or equal to 4. No. Then we will go to 1, and there, essentially now it will just not be possible for us to hit 4 ever, right? You will see 0, 1, 2, 3, 4. You'll see 3 is not possible, 2 is not possible, 2 plus 1 again not possible, 1 plus 0 again not possible. It's never possible to bring our goalpost back. You see how that works? So that's why this method is really good.